Well, afternoon again, ladies and gentlemen. We're now in the advanced materials for security and signature materials. And our first speaker this afternoon is Dr. Bernie Rickinson, who's the Chief Executive of the IOM3. He graduated in metallurgy with subsequent research activity at Sheffield and MIT involving solidification of metals. And Bernie was involved with NASA, Pratt & Whitney, and Riacast Corporation in the United States before returning to the UK. And currently, he's operating as the Chief Executive of the Institute of Materials, Mining and Minerals. And he has been actively involved, the Institute and its members, to support the work of the Materials KTN, and has taken a specific interest in broadening networking links between the materials and product design communities. And hopefully, at the end of the session, we'll have a short time for questions.
Well, good afternoon, ladies and gentlemen. I'm going to bring the subject area down to earth to some extent, because what I'd like to talk to you about is the prospect of innovation, and the prospect of innovation principally through collaboration, and the joy, if you like, of technology transfer. And I'd like to pick up a real-life example from Mark, because I think it was in about 2005, 2006, that the light bulb went on as far as the materials community was concerned, to realise that in many cases, and I'm in danger of sort of perhaps treading on toes here, in many cases it's not materials technologists that make these decisions of what to actually use or not. It's all about product differentiation, and in a lot of cases product designers actually know what hits the mark in a marketplace far better than a materials technologist, and that's an even better way in terms of in which to involve them. And this study that I'll show you, this case study, which is not rocket science, is all about harnessing individual opinion, coming up with collaborative effort, putting it into perspective, and delivering it within 18 months. So what we've got is a situation where we start with a question. What have all these things got in common? Well, yes, they're all materials, and I wouldn't necessarily come along believing that they weren't. But they all have, in fact, one common ingredient, and it's a bit sad, because the answer, as far as I'm concerned, is that they're all a part of a materials theft program appropriate to the UK, which is denuding its infrastructure to the tune of about $750 million each year. It's sad to some extent, because I've turned from being a metallurgist to perhaps a metallurgist come thief. I tend to go to places these days, casing places, of where the materials that are most easiest to steal really are. And this is born out of an activity associated with the materials KTN, and specifically embedded within the materials KTN, something called the Materials and Design Exchange, that really does try to push out the opportunity of creating interdisciplinary type of community activity. And we've developed a few products for effective networking, taking actually many of the examples of touch and feel and texture and emotion from the product design community to really get into a spirit of networking. We were drawn into this by the Home Office. I remember the phone call. Bernie, do you think you could help us within the KTN's activity associated with, well, the first one was glassings in pubs, designing glassware, the materials and their design by which we could reduce the number of serious injuries, and then following that, metal theft. And what we did in a series of innovative workshops, both involving lead and copper, was try to harness creative thinking and effectively bringing along a series of priorities through which we could address, in this particular case, metal theft. This was specific to the lead workshop, but when you started to compare and contrast the outputs both for lead and copper. There were some remarkable similarities. And this was the top 10. I like the bottom one, actually. Lead, actually, on roofing is an absolutely marvellous material. It's designed for the job. Has an amazing lifetime. But the interesting one here, there are no holes barred as far as whitewater innovation is concerned. A Viagra roof, something that's very pliable when you put it on, but then hardens appropriately. And I spoke to a polymer technologist the day after, and lo and behold, he said, I've got that. You needn't worry about that. I can do that with UV light without a problem at all. So all of these had a capability, but looking at these, we started to go down an interesting pathway associated with perhaps coming up with a potential solution. Being traditional metallurgists, we like process routes. I was hearkening back again to Mark's comments. Yes, you can have materials, but the influence that you can have on materials through their processing is quite honestly wonderful. And we simulated, if you like, where the theft opportunity was within this manufacturing route. This is heart-rending. Heart-rending in the sense that we've lost things in the UK. It's gone under the radar. We don't melt copper in the UK anymore. We used to, and we still do. You could argue for making bronzes and brasses. But in terms of primary manufacture for copper bar, rolling, forging, then subsequently drawing, we've lost that primary end. Therefore, copper scraps in the main that emanate from the UK go out of this country. And that's one of the problems when it comes to a crime, and is one of the advantages for the criminal community in terms of get it out of the country quickly, and who knows, we might not be caught. So we laid up a visualized supply chain of where we could make a difference, and bearing in mind those thoughts regarding how we could disrupt the crime chain, we wondered if we could create some form of immediately visible sign to help the CPS, the Crime Prosecution Service. Because they have a problem. And their problem is that they will not take to court and prosecute those people who they cannot clearly define where the material has emanated from. It's not worth the taxpayers' money. So what we tried to do on our plan here was to create, if we were to mark something, how could we do it? And here we had a sort of spot of luck in the sense that within those players within the knowledge network, we were clearly aware of things going in parallel domains. In the aerospace industry, in the automotive industry, where metal marking is taken for granted. It gives you all the information that you require in terms of date of manufacture, who's made it, how long that part's been in service, and so on and so forth. So we lifted that technology out into this type of application. We transferred the technology. And in doing that, we first looked at lead, and there is, after some feasibility work that we did in conjunction with BIS funding, we looked at the opportunity by which, with both portable and static units made by a UK manufacturing company based in Sheffield, we could adapt those techniques to create some further demonstration items. Needless to say, it started to work. What we were encouraged by was the British Transport Police, who have the national remit for theft across the land, as far as metal theft is concerned. And we also started to involve Church of England, ecclesiastical insurance, English heritage. People, quite frankly, that if I turn the clock back in my own lifetime, 6, 7, 8 years, I would have never been talking to. So this interdisciplinary understanding the customer's own need is quite powerful through this knowledge transfer networking. So this was something that we started to experiment with lead, and as far as the police were concerned, there are a number of forensic capabilities that already exist in the marketplace. They are effectively covert. One has to use somewhat more sophisticated analysis to say where that particular material's come from, and in the perhaps 9 days that it takes you to do that, the criminal has disappeared. Jump bailed a lot. So therefore what the police wanted was something that they could directly read. Now, we got clever to start with, actually too clever. We started putting QR codes and barcodes and things like this on. And we were drawn up sharp by the police by saying, look, do you think I'm going to, equip every policeman with a smartphone? Maybe in 10 years' time, but certainly not now. Generally speaking, they've got a pair of eyes. Can you give them something they can read on the spot? So it was really a matter of trying to create, as far as the police was concerned, something that was like that. We then ran into a bit of a problem because English Heritage weren't too keen on the fact of having these large signs all over their heritage buildings. So here we then start effecting an agreed compromise, and I'm pleased to say that we've achieved that and got now a system that both sides are comfortable with. Within the demonstrator that we created, we have the capability of laser engraving and dot marking, and some of this stuff is both static and mobile, or simply static, and we're looking at the opportunity by which we can provenance mark copper, principally cable, but we've done many other things more recently, and lead and other materials, and specifically that slide shows the sort of work that we did with English Heritage for lead. And I'm pleased to say that then people had the confidence of taking this compromise a stage further, and one enters then what I call lead heaven, which is if you come from Northampton and go to the Guildhall and somehow get yourself on the roof, it's filled with lead. Code 8, lovely stuff, very valuable, but fortunately in this particular case now fully marked. But just down the road, in fact about 200 metres away, St. Peter's was not so fortunate, and they had a lead aisle roof which was hit twice, and the first time that they knew that it was actually stolen was when the rain started pouring through it. And that's the unfortunate part about it, that very often these things are not that visible, and the police rescue perhaps the material but don't know where it's come from. So they can't advise the people to go look at your roof because there's probably going to be a bit of a problem tomorrow morning. So taking that a stage farther, we now think that in terms of these two buildings, well, since we've done them, they haven't been done, and we're working our way into other building areas using the same technique. Fast forwarding, though, we've been drawn quite earnestly into the areas of electrical power distribution. And there they have a real problem because in many cases this stuff is directly on show. And principally you're talking about copper earth strapping of this type of size, and this is dotted over. This is a big grid station. It has a boundary fence. It's got a lot of defences, but it has an awful lot of value inside it. And these are local distribution substations, the sort of tattered door that you pass, on most street corners. But inside there is a little bagatelle of materials that are well worth prizing off the wall or the floor. So our raison d'etre is to take our dot matrix printers in there, and that takes about 20 seconds to actually deliver, and you place these all the way down all of the earth strapping to give them a provenance. It's not the only thing. You need to deter, and that's signage, you need to record, and you need to give the police something like a DVLA database to work on so that they can immediately find out when this material is intercepted, whether it's intercepted at a scrapyard or by a policeman, or even in border control. They need to know exactly where it might come from. We've actually done now in the Northwest, for Electricity Northwest, we've actually visited 1,000 of these local substations within the last 6 months, putting this marking in. If you look at crime statistics at the moment, crime is down. Politicians would tell you that, and it's true, at least as far as metal theft is concerned, but it's actually ticking up, and it's ticking up in various areas, and yet again we have an interesting example that none of these stations have been interfered with. It surprised me that, again, something on every pavement these days are these green boxes sprouting up, not unnaturally, but when you have a look inside them, they've got really some nice assets. Principally these rather large, about 150 pounds worth of lead polymer battery. Fascinatingly, despite the cost, there's not a shred of provenance information on them, and therefore we were approached by Virgin Media to see if our technique could address this as a problem, and this is a sort of close-up, if you like, of what you get on that ABS casing. Depth of penetration is actually fairly small. It looks pretty large down there, but that's a high magnification shot. And exactly the same thing now is going to be used from the 1st of January next year on all Virgin Media batteries across the whole of the UK. They've bought into this, as it were, hook, line and sinker. You need to do some training before you actually go out and mark things for real, so there's a training activity and a database development that's gone on hand in glove over this last 18 months. And I'm pleased to say that in the last 12 months, this as a demonstrator activity has broken even. So from our point of view, this has been quite successful, not just from a technological standpoint, but also from a transfer into the marketplace. Problem is, police are always behind the game. They're reactive rather than proactive. So again, the materials KTN was contacted. Could one get ahead of the curve by predicting what the next material theft would be? This is some really quite elegant work. It's just straightforward data coming out of Greater Manchester Police in an operation they call Operation Alloy. And I'm convinced that organised crime actually has the LME up there all the time, knowing when it's worthwhile to go out and start stealing metals. But this is some elegant work that measured the offences against LME metal pricing. And it didn't really surprise us, but what did surprise us was the fact that within the police, within the Home Office, there was no methodical way of evaluating all of the information. So within the KTN, what we've been developing is something quite simple, which is forecasting, creating a weather forecast for materials theft. And we take pricing and business trends, news and media and crime data, plot it out, and then put a weather symbol, and as a consequence of that, make a future forecast. And this has actually been quite valuable in terms of saying, you know, I think that leather might be your next one. Leather's a very interesting story. Demand is doing this, supply is doing that, and the US national herd associated with leather, hides, is at a 60-year low. You know, if I was in organised crime, which I hasten to say I'm not, that's where I'd be looking. And I actually made this comment, it was about 2 or 3 months ago, to the Home Office, and 5 days later there was a huge robbery here in London on Bond Street with £200,000 of leather handbags being taken out. So I think materials technologists have got a lot to offer in terms of predictive thinking, and predictive thinking about the value and interest in materials. So I finish by saying Materials technologists talk a lot together. It's such a happy community. They do talk, they interface, they like interfacing, and they like to engage with societal issues. In this particular case, it came through into knowledge exchange with the KTN. It transferred in terms of a feasibility test, which my own institute got involved with, to the point of bringing collaborative effort together and forming a UK demonstrator, which goes under the name of Signature Materials. And I think within a relatively short period of time, we've done the job of transferring technology to address that particular societal problem. Thank you.